Welcome students. This is now the lecture on the next chapter on more objects, chapter 14. And I'm trying something a little different right now. I'm using Atom as my editor. It's a rather nice editor, colorful, and even though here on the side I have the code blocks open, if it should crash, we can still work with our editing. In fact, you can see right now it's giving me this little message that says this has been edited outside of the IDE. Well, that's good. At least it knows that I made some changes. And the way we're going to start this is, let's look at int main. So here's about lecture 14, or chapter 14, all the more classes. We'll be working with copy constructors, overloaded operators, and recommend you look at page 838 in the book. What can be overloaded, 844. Overloading the increment and decrement operator, mostly the increment, post-increment, and pre-increment, page 849. And we'll create this circle object. So all of the constructor information for the circle object I've put in ahead of time. Again, to save us the grief of having this always crash on us, and I'm giving you the code anyway. I've set up our input libraries, setting up pi as a constant. So if we ever needed that precision, we've got it. We've got exact pi. So we create a circle class. The private variables will be the radius, and this new static int for num count. That's one of the features that we're talking about in chapter 14. It's going to be a variable, and every time we create a circle object, that number will be increased. And we'll take care of that every time a constructor is invoked. So if in the course of a project we create 5 circles, we'll know that we've had 5. So we can call any one of those circle objects using the get num count, and that will tell us how many are out there, which might be a good thing if you're working with games and you have so many fireballs or something out there. You want to know how many you've got out there. The int count will tell you. And especially if you have a destructor and you destroy it, then you can decrement the count. But for now, we're just going to keep going up and up. All right, so here's all our public methods. Default constructor, a constructor with one parameter. Then the copy constructor. This is new to the chapter. We will be sending in a circle, and this circle will instantiate itself based on the circle data here. Now, obviously, it's just one data element, but if you had something with more data elements, then you send that in, and all of them will be extracted out. Okay, setters and getters, print method, toString method. Okay, here's the method for getting the num count, and down here are the overloaded operators. We will overload the pre-increment, post-increment, and the identically equal to operator. Okay, now since it's a static member, right outside the class, we will have to set it equal to 0. Okay, we need it set somewhere because we can't do a plus plus on something if it's got no data in it. And here's our first constructor. Create the circle, set the radius to 0 because it's the default constructor, add 1 to the num count. If we already have a radius, set the radius to whatever that value is, and again add 1 to the num count. And right here I'm going to say this using the arrow symbol. Okay, because the chapter is now first talking about using the this operator. Well, we've already used it last week, and we're using it now again, so now we can say, yep, cross that off our list. Chapter 14 talks about it, we've got it. The copy constructor. We will send in some reference of a circle object, and since we know about it, it's not private to us. We are, we're like a kindred spirit. If we're a circle, we know what we've got. We can see the other circle's object without having to call any getters. So we can directly access the private method, get the right-hand side CC, assign it to the radius, and once again add 1 to the num count. All right, set get get diameter is twice the radius, get circumference is 2 pi r, and area is pi r squared. The toString method and print method look exactly the same, with the exception of the fact that toString will return a string And of course, we'll convert the radius to a string. That way we're concatenating string with string with string. And here we'll just print it out. Okay, so there is a difference between toString and print. One returns a string. Maybe we need to parse it later or do something with it. The other one is just a printout to the screen. Get num count returns the number. Okay, so before we go into the operator overloading, let's have the main program fire some of these things up. We'll create a circle whose radius is 6. We'll print it out, and we'll see that we have one circle. Then we'll create 2 more circles, a default circle, a circle whose radius is 1.4, and then we'll look at the count again. We're going to get it both from C1 and C3. They'll both be the same. I'm sorry. This will now be up by 3. We'll get C3's radius, and we'll see if C3's radius was set to 1.4. So let's come to here, and that information that I just showed you is right around here. Okay, so compile, run, down there. There we go. Okay, so it's going to be spitting out a lot more, but here's C1's radius. I set it to 6, but it's coming in as a double, so we get all that precision. We have one circle, but when I create number 2 and number 3, now I've got 3 circles. When I do a get num count. Okay, now so the first radius, C3, has a radius of 1.4 because we'll be playing with that C3 radius in a little bit. Okay, so now I've created 2 circles, C100 and C200. They both have a radius of 55. Are they equal? Well, you just can't use the identically equal to operator and say if these 2 objects are equal, because these only work on primitive numbers, integers and doubles, and booleans and chars. But how do we use it for objects? Well, go back here. We had to overload it. Okay, so right up here in the constructor we created this friend operator. So these are all friends of each other. We can access them directly. We have to declare it as of type friend. Friend is discussed in the book. Bool is going to be the return type, and we overload the operator with the word operator, because what's going to happen is operator is going to be like a replacement. So like when the compiler comes along and compiles this, we're looking at it as equals equals. The compiler has now reinterpreted it as operator equals equals. We will send in 2 constants because we're not going to change them, and they'll be sent in by reference with the ampersand. And here's what it is down here. We just look at if the left-hand side of the radius is equal to the right-hand side. Now this LHS and RHS is important. When we add or multiply or compare, it really doesn't matter. It's commutative. You could have it on one side, but if you're overloading subtraction and division in which order matters, whether it's left-hand side or right-hand side, then this comes into play, and it's very important. So I highly recommend that you use LHS and RHS. I think our book uses left and right. Well, you get the idea. The order does matter in some of these operations. Subtract, division, modulus. Okay. Since we have the overloaded operators open, let's say, I think it's really cool the way C++ overloads the increment operators, because you can say something like I++, it'll add 1 to I after you use it, or ++I, it'll add 1 to the I before you use it, so you'll see that it is incremented. So how do you know which one is which? Let's come down here and look at it. Okay, this is the pre-increment. It adds 1 before it, and then we send it. So easy enough. Add 1 to the radius, and then return an object of this reference. All right. The post increment, how do you tell the difference? Very clever. Here you send in a void, here you send it in int. It doesn't matter what you send it in. When the compiler comes along and sees that, it says, okay, This is going to be post increment. We will do it after we use it. So watch this little trick. We create a temporary object of circle and set the radius to whatever our original radius is. Then we add 1 to the radius, and we trick it by returning the temp. So remember, this adds 1 after we use it. Very clever. Create the temp, then add 1 to the radius, then return. Okay, so as we see it down here, we will create a C3 radius. We know what it is. And then we'll create C4 with C3's information. This is a copy constructor example. Then we'll create C5, which will be C4 with 1 added to it. And we'll look at the C5 radius to see that it's the same as C4, but C4 went up by 1 because it's post increment. We will create a C6 circle, add 1 before we send it to C6. C6 should be this new C4 added by 1, and then the C4 just to print it out to prove that it hasn't changed. So when I go back, I made some changes here, as you've noticed. When I go back here into code blocks, it should tell me I made some changes. Wonder why it's not. Oh, maybe I didn't save it here. Okay, Control S. There we go. Yes, I made changes. Yes, I want to keep them. Okay, so this is what we're interested in. So let me compile and run. Okay, so let's compare and let's look. So when we get to here, we've compared that the C100 is identically equal to the C200. I think what I'll do is I'll make a little change to it so that way if we run it again, we'll see that it's not equal. The C3 radius is now 1.4. Okay. We will create a C4 object with a C3 and we'll print that. That's also 1.4. C5 will be assigned C4 added by 1. Well, since we add 1 to it after we use it, C5 should still be 1.4. Good. We print out C4 again. It better be 1 more, 2.4. By the way, yes, you can use the plus plus and minus minus increment and decrement operators to numbers of type double. Usually we like to reserve that for integers, but it works just the same for doubles as well. Okay, so let's see, where were we? C4 had 1 added, so now C4 is 2.4. C6 will be assigned 1 more than what C4 is, so it's 2.4. It'll now be 3.4, and it is. And when we print out C4, there it is as 3.4 because we added 1 to it before we used it. So let's just do one last thing. Let me make this a 56. Save it, compile and run. And we should get a not equals to when we run it. And there it is, not equal to. Okay, so I didn't get a chance to do much coding, but I am going to be giving you these files, and what I will do is I'll put this back to 55 so you can play around with this. Very simple stuff here, mostly because it's just one parameter, the radius. But if you have other things like, think about it, you have a cylinder with a certain radius and a certain height, and it is possible to have 2 cylinders of the same volume if you play around with the radius and the height a little bit. So if you want to see if 2 cylinders are identically equal because their volumes are the same, they could have a totally different radius and height, but when you run the calculation of what pi r squared h, which is the formula for the volume of a cylinder, you run that. If the 2 of them are equal, within a little bit of tolerance, some small epsilon, then you can say that they're equal. So right now it's pretty simple, but as you go into bigger named objects, you might want to have other ways to compare, which you'll find in the lab and which you'll find as examples in the book. So this very, very short lecture is now giving you the big picture of the important components in Chapter 14 for you to be successful with the lab. Okay? Thanks for watching, thanks for listening, and until next time.